joining one more cmBuilder workshop. Right, today we have Godzilla as our big theme over here. I haven't watched the movie. I think the last movie, the Godzilla movie that I watched was the 2001 that goes inside like middle of New York, and Matthew Broderick is the hero of that. But that's my fantasy memory of Godzilla. But let's go with that. Okay, so today we are gonna really focus on terrain customization, right? So this is something that a lot of people have been requesting support for, training specific for that, and I just thought that would be like a good thing for us to really dive deep on the technicalities on how to use these tools, what are the type of data that we can use to bring into cmBuilder, and how fast we can create a custom terrain inside cmBuilder, right? So Javi will be here with me to help me with the chat, with the QA, and also give me some insights as usual. And the recording of the session will be available in 24 hours on YouTube. We have a lot of workshops over there. If you're new to these sessions, please go check them, because like there's a lot of powerful information over there to help you work efficiently with cmBuilder, and use the QA or chat function over here in Teams if you have any questions. Cool. So let's dive into it. Okay, so what is the custom terrain tool in cmBuilder, right? So when you create a project in cmBuilder, the original terrain that shows up in there is a terrain that it might not be necessarily accurate related to the survey data that you have about the area, with the drone scans that you have of the area, because this is coming from a satellite scan, right? So all the shapes that you see over here of this topography is coming from a satellite scan. So of course it won't be as accurate as your survey data or your drone scans or your air scans, okay? So let's understand how we can improve this. And it's very important to understand the difference between creating a terrain that is the existing terrain that you have at your site at the moment, compared to creating a terrain that is proposed, right? Like, what is the proposed terrain that you have? So our main suggestion is for you to focus on creating the existing terrain, because you're going to use the excavation tools in cmBuilder to manipulate that terrain and replicate the actions that you're going to have in real life to achieve like the shape of the proposed terrain. However, sometimes you want to focus on creating something that's like a marketing piece, or something that you want to just show what is the final stage of that terrain, and so on and so forth. You can also create the same thing, use the same tools that I'm going to show today to create a proposed terrain. But keep in mind that you can only use one terrain at a time. So if you use working with the existing terrain, that's the only shape that you're going to be able to customize. If you want to working with the proposed one, that's the only shape you will be customizing. Okay, so there's no way that you can import, at least for now. This is a plan that we have for later, that you can import two terrains and then like start with one that is existing and then finish your simulation with the proposed one. Cool. So to get to the tool, you just open the project setup in cmBuilder, and you click on custom terrain. The tool is right over here, and that's where we're going to be using it today. What are the options available for you to customize your terrain? So you can import a mesh from drone scans, from beam surfaces that were created in AutoCAD, in Civil 3D, in Revit, or you can use the BLOSM import. So BLOSM import is something that we already covered in past sessions. Basically, it's a Blender add-on that grabs the information of the 3D model of the area from Google Maps, and you can also use the tools that I'm going to show here today to create your terrain from that new surface, right? The second option is to use points, right? So points that can be brought in from point clouds, from point tables, from your surveyor trades, from contour lines, from survey drawings, and you can also do that on freehand, right? So I'm going to show a couple of these options. But before we start, I really want to give a big thank you to Kyle and Ben, because they gave me access to the a simple project on their end to show how we can import these information from drone scans. So Kyle gave me access to a propeller, a project, and Ben gave me access to a drone deploy project, and I'm going to show both today. So big thank you for these two awesome guys. Okay, cool. So let's start with the option of importing a mesh. So when I click on custom terrain over here at the bottom, you're going to see that at the top, we have the create terrain using meshes and create terrain using points. So the mesh, for people that don't know the lingo, is just a surface, right? So it's a geometry that is one surface that represents like anything. And in this case, we're using meshes to represent terrains. Okay. When you turn on the tool, the custom terrain tool, like this topography line filter is going to be applied over here on the top, and you will be able to see what is the existing condition of that terrain that was created by default from the satellite map. You can always choose to turn this on and off. And okay, so the cursor can be highlighted. Is it hard to see my cursor today? Okay, let me see if I can change. Um, Probably it's going to take me a while to change this, so I will try to use. Okay, I move it pretty fast. Sorry, I'm gonna move a little bit slower. Maybe I drank too much coffee this morning. My Tim Hortons cup is right over here to help me with that. Okay, so yeah,
Pedro,
so basically,
Pedro has very strong hand-eye coordination as the lead guitarist in Three from the Bay. Look him up. Look him up. You can't help
yeah.
but just work the fingers fast. Go ahead. Go
Yeah, so the tool is inside project setup, and then inside custom terrain over here. And then you have the ability to turn on and off these topography lines to show just like the control lines of the existing terrain that we have at the moment. Okay. I will open up, like go back over here to my PowerPoint point to show what we will start with the mesh process, right? So a mesh can come from like several different sources, but what you need at this stage is a 3D surface that's coming from somewhere, like that would represent the existing terrain, right? And the compatible formats that we have today is today we can only use GLB files to create the terrain, but we are planning to also allow the usage of FBX, IFC, and Revit and step files to create the terrain as well. Common data sources for this type of information, it could be like mapping platforms like Propeller, Drone Deploy, Pix4D, and a bunch of others. But also people would have like Civil 3D shapes, AutoCAD shapes, and like shapes in Revit, and so on and so forth. The geolocation at this stage for this process is kind of like an indirect geolocation, because the GLB file won't carry any geolocation, but the GLB file will have an origin point, and depending on the other references that you have, you might import something else that is geolocated like a 3D model, and then you can use that as a reference to geolocate your GLB file. So that's an option as well. Cool. And there is another way that we can kind of force a geolocation as well that I'm going to explain in a minute. So the process is we're going to export a surface from somewhere, like a drone a scan or a beam software. We're going to import that surface into cmBuilder, position that surface where it's supposed to go, and then we're going to generate a terrain from that surface. Okay. So let's start with the process of using mapping platforms. So mapping platforms can be Propeller, Drone Deploy, or any others. And the first idea over here is that we're going to export an OBJ package out of these platforms. And an OBJ package is just like a folder that would have an OBJ file that is a 3D surface file, MTL, that is the texture mapping file, in a bunch of texture files, right? So if I open over here, the like an OBJ export that comes out of, let's say, for example, Propeller, you're going to see that you have like an OBJ file, an MTL file, and a JPEG file that is the textures for that model. But if it's the OBJ coming from drone deploy, depending on how things are, you have like an OBJ, an MTL, and then a bunch of texture files, right? So depends on how this drone scanned that area and how complex would that scan and so on and so forth. Cool. And once we export that, we're gonna bring that information inside Blender, which is the software that we use a lot for these type of processing. And Blender is a free software, so anyone can simply download that. And then from Blender, we're gonna export a GLB file. There are some things about Blender that I'm not gonna cover today, but I really invite you guys to go check the user workshop that Callum did in December. And I'm gonna put the link for you guys over here. Which one is it? This guy. So import mesh data, crop. Okay, so I'm gonna copy this at a specific video point because the first part of that video is just related to how we can bring the information from Google Maps, but all the other stuff that Callum like talks about over here can be applied to the things that we're gonna talk about today. Okay, so I'm gonna send over here on the chat for everyone to go check or bookmark that. Cool. Okay. So let's start with Propeller, right? So some of you might use Propeller, some of you might use Pix4D. Today I'm gonna just, drone deploy. Others might use Pix4D, near maps, and a bunch of different other services. But today I'm gonna focus on only these two, okay? So when you have a project in Propeller, like you have the ability to go over here in outputs. When you click on outputs, basically you have like your 3D model over there of that area, a 3D scan that you created, right? So in this case over here, it's this little guy. Okay, so there is a 3D scan for this area over here, right? So it's kind of like delayed my navigation. Anyways, so this 3D scan, you can export that from your files. And in here, we're gonna use two options today. And so I'm gonna already show you where are these two options. So we're gonna use the 3D model option and the point cloud option. So I haven't yet explored the terrain one because these files can be a little bit complex to work with and to convert and so on. So I'm just gonna explore the 3D model and the point cloud one, okay? A 3D model, you're gonna focus on bringing in a OBJ file. So we have this guy over here. So when I click to download this, I will have something, I will have exactly what I showed over here from Propeller, these three files that we're gonna use, okay? So this is for the 3D mesh part, and the point cloud part, we are gonna use the LAZ files. And I really suggest that you use the WGS84 option instead of the other two, just because this one comes in meters, and then like there are some conversions that might be a little bit weird because like of feet and meters, because the geolocation system might be referencing feet and then your point clouds in meters and whatnot. So it's easier if you just try to use WGS84 and with your UTM zone, because this will give you a better understanding of that area, okay, in terms of unit conversion. So I'm not going to download this here because I already have it. And the idea of doing the same thing in drone deploy is that you can simply take a location and you can click on export over here at the bottom. And then from here, you have the option of exporting a point cloud and a 3D model. Okay, so the point cloud, when I click over here, it will give me the option to download an LAZ, XYZ, or RCP file. I usually use the LAS or LAZ. And I will set up my coordinate system over here to be WGS84, just because it's going to be easier for us to locate these elements in cmBuilder. The resolution that will be exported over here can be selected to be max points or like 0.5 million points or whatever quantity of points you have over here. But I really suggest that you do 0.5 million because the total, the maximum points that you can import into cmBuilder is only 10,000. And so like if you do the 0.5 million, we're still going to reduce this even more. So like it's easier to download like a smaller file. Cool. And the same idea from drone deploy for you to export this 3D model is to go into the model over here and then export an OBJ file, and that's the only setting that you have to place, and you're gonna get that package of files that I mentioned over here. So it's gonna be like a zip file that you're gonna get from both the 3D model or a point cloud, and when you open the 3D model, it's gonna be the OBJ, MTL, and all the textures. Cool. It's important to have those three file formats in the same folder because it will take a little bit. It will give you. It will be easier for Blender to find these textures and apply them to the right faces. One thing that I just found out while I was preparing for this call today about drone deploy is that you can create some points in drone deploy. You can place a point over here by using this kind of like point location. And when you place a point at a location, it will give you the elevation of that point along with the lat and long. It might be interesting for you to check this first, and then when you create your project in cmBuilder, you use the same lat and long or to create that project, because then like there will be an easier placement, because like the origin point of your map and the origin point of this mesh and this surface will be the same, right? So that's a good thing to do. But it's also important to get this point or like any control point from your scan, because we will need the elevation for that point, right? So when we place that surface in cmBuilder, we still going to need to move it up and down, and knowing a specific elevation for a specific control point will help you a lot with that. Cool. Okay, so coming back to this, so basically from propeller and drone deploy, we can export the obj and everything else, or we can export a point cloud as well. Okay, so what I mentioned over here about trying to match the origin points when you're creating a project is basically that. We're going to bring that information into Blender, and we're going to export a GLB file. So another way to create this, like to have a reference shape for you to manipulate in Blender, is whenever you have like this shape created from any BIM software, right? So usually people, at least from like what I've seen in our customers, people will use Civil 3D, AutoCAD, or sometimes even Revit will have that shape, right? So if that's the case, like again, thank you, Ben, for sharing this Revit file with me. But like this is a situation where you have like a 3D model from Revit that has a topography surface in here available, right? So we can use that topography surface as well. And the way to export this, to bring it to cmBuilder, when you have that available, is there are many ways, but like you, what the main focus is for you to convert that surface, isolate that surface and convert it to an FBX file. So from Civil 3D in AutoCAD, you can open that file directly in Navisworks, the DWG file directly in Navisworks. You isolate the terrain, and then you export an FBX out of that. From Revit, you can do the same, but opening Revit files directly in Navisworks will take a long time. So I put over here some alternate options for you to use with Revit. So basically, you can take this Revit file, and we can isolate just the structure, or just the topography over here, going into our visibility graphics. And then you can just hide everything that is not your topography. And then you bring in your topography as a reference. When you hit OK, then your topography will be isolated over here. From here, you can go into your file, and then you can export this file directly to FBX. That works fine. You can also export this as an IFC, or if you have the plugin available, you can also export NWC. Exporting a file from Revit to NWC and opening that in Navisworks is way faster than opening the Revit file directly in Navisworks. That's why like this is an option that I use it, not just for like terrain customization, but for many other elements that you want to, many other things that you want to do in terms of like file conversion. But exporting an FBX, this is actually the only situation where we suggest that you can export an FBX directly from Revit, okay? And the other option is that you export an IFC and you open that in Blender directly, but you will need an add-on called Blender Beam that is also a free add-on. Cool. So these are the options that we have to bring a 3D shape into Blender. And the main reason why we want to bring this into Blender is because Blender will allow you to isolate the terrain over there and export a file with the correct file format that we need. That is the GOB format. Okay. So I already have like one of these surfaces from Drone Deploy, the one that Ben shared with us, available over here in Blender. And I'm going to show a couple of options on how you can isolate the terrain on this area, right? So I'm not going to focus too much on that because Callum already like talked about that on his presentation. So the link is over there in the chat and you guys can go there and check it, okay? So let me open this now. What can we do in Blender in terms of like adjusting these surfaces? We need to isolate the terrain because your drone scan is going to have vehicles, vegetation, buildings, maybe stockpiles that you don't need and things like that. So you need to isolate the terrain that you want to see in cmBuilder. You can adjust the surface resolution. So drone scans will create surfaces that are quite heavy and detailed. So like this surface over here has like 2.7 million triangles. So this will generate a very large file. So you are able also to reduce the resolution of that because we don't need that level of resolution to create the terrain sim builder. And we're also going to use Blender to convert files basically. Okay, so I just imported my OBJ file into Blender by going to File, clicking on Import, and then clicking on Wavefront OBJ. So when I do that, like you see that both options will show up over here, MTL and OBJ. So we're going to select the OBJ. And it's important as well for you to define the up axis. So one thing to know about Blender is that because this is not a 3D modeling software focused on construction, several times Blender will consider that the y-axis is pointing up instead of z. So whatever you can to, especially on converting, importing models and exporting models out of Blender, there will be an option over here for you to define where will be the axis that's pointing up, right? So if I click OK over here, I'm gonna get exactly the same model at this location. So what can we do with this? Like at this stage, we are gonna do a couple of options. So because this model is quite heavy and quite detailed, I'm gonna click on this. I'm gonna click on the model, and then click on this little monkey wrench over here, and then I'm gonna add a modifier. So a modifier in Blender is just like a quick action that you do to that whole shape, and you can, for example, decimate it. So if you go into Add Modifier, Generate, and then Decimate, this will give you the option to define a ratio in which you want to reduce the quality of that shape. So I'm just going to put like any random ratio over here, like 0.3, and you're going to see that the face count that is like 2.7 million, we reduce to something like reduce to the amount of face count defined by that ratio, right? So probably I should haven't done that because it might take a little bit while. But basically, every time that you add a modifier to a shape in Blender, you need to apply that modifier afterwards, right? So that modifier will stick with that shape. Okay, so let's wait for this. There you go. So yeah, the 0.3 ratio gave me now 800,000 faces on this shape. So this is, I don't know like exactly how much I need for this area, but I'm just gonna apply now this modifier to this shape, and this shape will stick with the resolution now that we have created for it. Okay. After that, the reason why I decided to decimate this first is because all the other actions that I'm gonna do now in Blender will be faster, right? Because we are gonna be working with a simpler geometry basically. Cool. So for those of you that haven't yet used Blender, you can download Blender from their website or from Microsoft Store directly on your computer. Okay, so now I have a shape over here that is a little bit simpler, and now I can try to isolate the terrain on this shape. So I'm gonna do like a very quick one. Basically, we just need to go over here and click on edit mode, and this will allow us to now like visualize every single one of the geometries that create that shape. So there are a couple ways that we can visualize this geometry. So if you click on this little button over here, you select the vertices that created these triangles. If you click on this other one, you will select the edges. And if you click on this one, you're going to select the faces, right? So it really depends which one, what you're going to use. I prefer to keep edges because from a zoomed out perspective, the edges will give me a better view. If I change this to vertices, it's harder for me to see exactly what that geometry is. Faces is even worse. And you can also use some tools over here to snap your view from Z option and so on. And the simplest way to do this is to do a lasso selection on specific parts to remove those parts from our main surface. So I could spend some time by going into my lasso selection over here and then select a couple of different ways to select this element. So like I can do a selection box like this one. I can do a selection circle where it's kind of like a brushing movement over here, but it's super slow to do that. And the other option is the select lasso. So select lasso, it's a kind of like a free form selection that you draw, and it would take a bunch of parts out of that shape, right? So my personal preference is just to remove the buildings, to remove the trees, and so on and so forth. But this might take a while for us to show you today. So in this case, I'm gonna just go ahead and do a lasso selection over here to take only the area of our project. So now that I selected the area of our project, I can right click on this shape, going to separate by selection. But it's very important as well for you to have this X-ray option selected over here and this option for the viewport shading, because if I deselect the X-ray, now I'm only selecting the parts that are in front of me, but not everything that is behind it, right? It also depends on how far you are from the geometry. It will affect your selection. And if you are working with this view, which is the default view for Blender, you won't be able to see the textures. Everything will be in gray. So basically, you just need to toggle X-ray and toggle this third sphere over here to get the correct view for you to select things easier. Cool. So I'm gonna do my selection, and then from here, I'm gonna right click and then do separate by selection. So this now will create a new item over here in my tree structure, and this item will be representing the new shape. So if I go back to object mode, I will see now that this item is the outer part and this item is the inner part. I already did like a filtering over here to remove a couple of parts, right? So remove the streets or isolate the streets and so on and so forth. So you can choose what you want to keep as your main reference to bring into cmBuilder. And after you're done with this, you can go into File, go into Export, GLB. So a GOB, which actually is showing over here as a GLTF 2.0, but if you look at right beside it, you see that there's a .glb over there. So when you go into the GLB and you have like elements that are hidden in your view, you can choose over here on the GLB export what to include. If it's only visible objects, if it's only selected objects, and so on and so forth. I prefer to work with the visible objects, and then I just hide whatever I don't want, right, in this case. And then you can also expand the transform and deactivate Y up, because this comes in activated by default. So you deactivate this to make sure that your Z is going to be pointing up. After that, you're going to export and you're going to get like a file. In this case over here, I got like a 500 meg file. And you see that I had some failed options over here. Just this was like a quick, it was a Blender thing. I just like close and open again. And then when I exported exactly the same thing, I got like what I wanted. Cool. There are many more things that you can do with Blender. Blender is a very complex and complete tool, but we won't be able to go over that today. Cool. Once you're done with that, and reminder that you can also apply that to this shape over here. So when you export this shape as an FBX from Revit, you can also import that shape by going over here and then importing an FBX file. So this will give you that shape inside here, but like the colors might be a little bit different. It might be different from what you have in Revit and so on and so forth. But it's also an option, right? Depending on what you have available for you at the moment. Cool. So once we export that surface out of Revit, out of Blender, next step is to bring in that surface into your scenario over here, right? So if I go into buildings, imported mesh, you can import a mesh out of like from the GLB file directly, but I'm gonna be using now like an existing GLB file that I already like created over here. So it's just that same file that I showed you guys in Blender, this same idea. Cool. It might take a while for this to show up, but basically the model is going to show up in a specific location. And from that specific location, I can go ahead and position it on the right spot by using the movement tools that we have. So let me see if I can force this to come in a little bit quicker over here. So it's loading the mesh. This might take a while. So while this is loading, let's go back over here to see what will be the process that you have in cmBuilder, right? So you're going to import that mesh into cmBuilder using the import mesh tool, and then you're going to position that surface with like all the commands that you guys already know, like double clicking it and then moving it up and down, rotating, and so on and so forth. Or you, but remember that the geolocation is possible if you already have like an FBX or IFC counterpart that is geolocated in cmBuilder. And from that, we are going to generate the terrain. And once you generate the terrain, you can actually remove the surface afterwards because that surface, it's already created the terrain, but you don't need it anymore. So it's taking a while for this to load because that surface coming from drone deploy, these are very high quality surfaces. So like it takes a while for them for the product to render that. Okay. But while this is loading, let me see if I can open something else over here as an example. Just so we won't lose good time. Okay. So let me go in here because I know that the scenario has a surface that is easy to use. And buildings, models, there you go. Okay, so let's say that I imported the surface at this stage over here. I'm clicking fast over here because I wanna just delete what I have done already. But let's say that I imported the surface and it shows up on my view like that. You can double click on that surface and you can move, rotate, and snap it to whatever location you want. And it really depends on like what is the quality of your surface, what is the textures that you have applied to them, because you can use those textures to quickly reference the background and so on. And the idea is that you just need to go and move the surface to a location where you know that it's what it's going to be. And if you know a specific elevation point for that surface, you can click on the user defined handles display, click on relocate handles, and then you click on the point that you know what is going to be the elevation for. And in here, now you can define what is the elevation for that point by typing it in here. So if you go and put in like 325, this will move that surface. So that point is at this elevation. That's why it's important for you to know like a control point that you can simply type in the elevation and the surface will show up at that location. Oh, I was not expecting this to take this long to load. So let's keep on going. Uh, something that I'm good on is improvising. So let's go ahead with that. And then once you have the surface located at the right spot, you can just now go into create a terrain mesh, right? So you're going to open your custom terrain tool, click on create terrain mesh, and you're going to see your surface over here at this list, right? So when you click on that and click on load, it will show you like a couple of options over here. So you don't need to worry too much about this, but one thing that is important is to define a good smoothing distance. Usually I bring this up to like the middle over here, something like that. And this the smoothing distance factor, what it does, it defines how further away from your surfaces you're going to propagate the impact of that terrain customization. Because if you look at it from above, you see that the surface doesn't cover the whole terrain. So how far I want this change to impact the rest of my terrain that is not covered by the surface. This is defined by the smoothing distance. Cool. So you can play around with that and you can click on generate preview over here. This is going to take some time and then it will create a new terrain for you. And you see how this is overlapped now with my new surface, right? So you can define, like, for example, if you want to set this as your initial terrain, and when you hit save, now you have a new terrain to work with. Cool. So as I mentioned before, you can, now that you already use the surface that you need, you can double click on that and then you can remove that surface from your scenario. And this is not going to impact your new terrain. You're still going to have your new terrain working for you. And the idea is that now you have a better and more accurate shape for you to work with your excavations, with positioning your models, and simply planning your logistics of your site. Cool. Oh, does it finally finish loading this? I think that's because I'm like in a room at the office that doesn't have like a very good internet, so that's probably why it's taking this long to generate. But as you can see over here, the surface is generated for me, and I already positioned it like aligning the edges of my surface with references that I can see on my satellite image, right? So this is how I usually position these elements, and then you can set up the smoothing distance and the blending method and whatnot. In this case over here, I decided to bring in the stockpile because if you want to start from the point that you have at the moment on your excavation and things like that, you can bring it like this so you can represent that as well. Cool. So there you go. So this is the process for us to create a new terrain in cmBuilder while using a 3D surface. If you guys have any questions about that, please just drop in the chat right now in the QA. I'll be happy to go through them today if we have the time. Cool. The next step is to now let's understand how to create the same thing, but instead of using a surface, we're going to use the points coming from a drone deploy or from propeller. What is the advantage of using points? It's because the points will be geolocated, right? So when you export a 3D a point cloud from drone deploy or from propeller, you're going to define what is the geolocation coordinate system that you're going to use for that, right? So you would download a file that is going to be an LAS or LAZ file that we need now to simplify that file somewhere because those points are going to be too much. We can only import up to 10,000 points in cmBuilder. So usually you're going to bring in like 500 thousand, a million points, 10 million points. Like point clouds are very, very heavy, right? And so we need to have a point table that will be geolocated and would be less than 10,000 points.
Yeah, so what we need is a geolocated point table that has less than 10,000 points. And the comparable file formats that we have today is the CSV. And we really, you have to use a template that can be downloaded. When you click on points over here, there is a download template option for you. It's like the template is very simple. Basically, it's just like the headers to let us know like what is an X, what is Y, and what is Z, and that they should be in meters, basically. Okay. So from that point onwards, what are the different sources that you might have from this is mapping platforms that like Drone Deploy Propeller, or like your surveyor might have that available somehow, and so on and so forth. Sometimes people can create those points from like 3D surfaces in Civil 3D, AutoCAD. There's a bunch of options where you can create those points. And the idea is that the advantage of that is that this is going to be directly geolocated at your site. Okay. So the process is we're going to export those points, we're going to simplify that, import it, and then generate the terrain. Okay. So if your points are coming from a mapping platform like these ones that I already downloaded, we now need to define how we're going to isolate the terrain from the rest of the points, because when you download this information, it's going to be exactly what you have over here in terms of in terms of like the points will represent vegetation, buildings, and so on and so forth. So there's this other software that is also free that we use a lot over here that's called CloudCompare. So CloudCompare, you can simply download in your computer. It's very quick to use. And the idea of CloudCompare is that you can import a 3D point cloud, just like this one, by simply, like it will start from scratch over here, by simply clicking on the open option. And then you're going to find your LAZ or LAS file. You hit open. There will be a couple windows over here. I simply just go with apply all. And this window is just showing you that there is a coordinate system applied to that point cloud already. And at this stage, we are going to, for this session, we're going to bring those points to a local coordinate system. But when you export it, you will push it back to where it was before. So you just need to hit yes to all over here, and then your point cloud will show up in this software. Okay. So before I start with this software, let's understand what we're going to need to do at this stage. We need to crop the area to focus on the area of our project. We will isolate the terrain from the rest of the points. We will subsample that point cloud to, what is this? It's actually merge point cloud. So let me change this. We need to subsample that point cloud so you have less points. And as an optional like step, you can also merge different point clouds. Okay, so let's start the process in CloudCompare. And over here, the first thing that we need to do is to select that point cloud. And we're going to click on this little scissor over here. So the scissor will allow you to create like a polygon that will define what is going to be cropped out and or left from the final output. So to do that, usually I go into my top view, that's over here in the top. And depending on how things are, like sometimes drone deploy will create points that are super low over here or super high and not. So you might need to do some cropping looking from the side, but usually I just start with like cropping that looking from above. So we're going to click on the little scissor and we're going to go ahead and select a polygon that will define the boundaries of our output. You right click to confirm the polygon. And then over here, you can choose if you want to keep what is inside or keep what is in the outside. Okay. So after that, you just hit confirm. And now you have 2 point clouds over here. So if you deactivate this, you see that that part is gone. And if you deactivate this, that part is gone. So we want to keep this one over here. And now the next step is for us to separate the points from there on the terrain from the points that are above the terrain. So this is a very smart tool that CloudCompare has that's called CSF filter. So if you go over here in plugins, it comes already with the software. You don't need to download this plugin. But if you click on CSF filter, you can go in and there are some parameters over here for you to choose. Usually I just choose a steep slope. I keep my slow processing in advanced parameter setting. I put my cloud resolution to 1. These are the only changes that I do. And what does this process does? It takes it's quite smart actually. It takes your point cloud, put it upside down, and then drops a piece of cloth, a virtual piece of cloth on that. And that virtual piece of cloth is going to touch a lot of points. And those points that it touches will be considered ground points. And the points that are not, the cloth is not touching is going to be considered off-ground points. So if you imagine that this had like a lot of buildings over here, when you invert that into the piece of cloth, the buildings will be like openings on that. And the piece of cloth only deforms a little bit. So the sides of the buildings and the top part of the building won't be selected, basically. Cool. So now I can choose over here if I want to, if I deactivate the ground points, you see, these are all the parts, all the points that are represented over here that are not on the ground. And if I keep the ground points, these are the points that are on the ground. So it's quite smart. I really like this tool. Cool. And the next step now is for us to select this and see how many points we have left on this point cloud. So my point cloud was exported as a 500,000 points, but after what I did, I'm left with 380,000 points. That's still too much. So we're going to subsample this to bring into cmBuilder a total of a maximum of 10,000 points. And the way to do that is to click on this subsampling point cloud tool over here. And there are 2 options that I usually use. So one is a spatial, where you define what is the minimum space that you want those points to have. And over here, I would suggest that you use like either 4 or 3 meters, because if you do like in cmBuilder, if you want points to be closer than that, it doesn't necessarily give you like a better resolution, because it's just like a technical limitation that we have. So like you should put like in terms of minimum spacing around like 4 meters and something like that would be already good. But sometimes even when you do that, let's say that I put over here 4 meters and I hit OK, even when you do that, you might not be left with you might still have like more points that you can have. So you might still need to do other types of subsampling, right? In this case over here, this subsampling gave me like almost like 2000 points. So let's say that I want to keep my resolution a little bit higher than this, and I want to focus on getting like the maximum resolution that I can. So I'm going to go into my subsampling, and I'm going to go into random, and then I'm in the remaining points over here, I'm going to type in that I want to keep 9000 points. So this will randomly remove points from that surface over there to keep only now 9000 points. Okay, so these are the three steps that we have. You crop the part, you crop the area, you separate ground from off ground, and then you subsample it to have the limit below 10,000. Javi, do you have a comment?
I was just going to say that in the chat, Eric put a good tip just around if you're using Revit for this, that the environment plugin for Revit has some great tools in modeling and topography. So maybe everyone saw that chat message by Eric, but just wanted to say that specific to Revit, it sounds like there's a plugin there that you could use to get your numbers down as well, just as another option. Thanks for sharing.
That's great, Eric. Thank you. I didn't know about that, and I'll definitely explore it to see if that's a good solution for us to suggest as well. Okay. Yeah, so basically now I'm left with the points that I need, right? So I have like the other thing that I said that it was optional, like about you merging point clouds, that sometimes you are doing this process and your area is too big and you want a specific area to have like a better resolution or something like that. You can crop that area like from before you subsample it. You say, for example, I want like, I don't know, this area over here to have a better resolution. So you crop that area, and then for that area specifically, you keep for that area specifically, you can do a different type of subsampling and so on and so forth, right? So this is an idea that you can choose. Okay. So let's go back to what it was before. So yeah, so like I will, after you do that, if you have like 2 point clouds that have different resolutions, you can select those 2 point clouds and then click on this button over here, and you're gonna merge that point cloud. It will give you this change of color that's called scalar field, but you can go over here in colors and change to RGB. So it will show you like the original colors of those points. So if you zoom out, you're gonna see something a little bit closer to what you had before. Now, the next step is for us to save these points in the format that we're going to use in cmBuilder. So if you select the part that you want, that you're working with, then you click to save. And now you're going to save a task points. So usually over here, I already put like a .csv because we will force this file to be a CSV format instead of any of the other formats that are showing over here. When you hit save, the last thing that you need to do in CloudCompare is to change the separator from from space that will be the default to comma, right? So when you export that, now you have a CSV file to work with. And when I open that CSV file, that is this guy over here. Where is it? Where is it? Where is it? This is what I'm going to get, right? These 3 first columns are what we need. All of the rest is garbage, so we can delete these. And we're going to go and insert a new row over here because I need this template, right? So this is the template that we downloaded from cmBuilder. So I'm just going to copy paste this guy over here. So this X and Y function, it's following the geolocation of each one of those points. So these are actual like the coordinates for those points. And the Z function is just the elevation for that point, right? So when you have this done and you save it, now in cmBuilder, I'm going to go in and import that point cloud. So just starting from scratch again, if I go in create terrain from points, then I'm going to need to import that point cloud. And you can only have like a CSV file. Once you upload that file in here, you're going to get like a selection for you to define what this point cloud is going to be referring to. If it's going to be the scene, the scene XYZ definitions, or if you're gonna which georeferencing system you're gonna use, right? So the georeferencing system that are available in here, you need to define it at the project level. So when I open that project page, Give me a second. Let's go. Project page. There you go. So when I open that project page, I can go into project settings and then go into coordinate settings, and you can see all the georeferencing systems that I can use in this project. So you can add new georeferencing systems over here, and depending on where you're bringing this information from, you see over here my point cloud that I downloaded from Drone Deploy is showing me over here the EPSG code 32616. So you can just type in over here 32616, and that will show. It's not showing because it's already here, basically. So once you add them to this list, they will be available at this stage. So at this stage, I'm going to select that specific UTM coordinate system, and I'm going to hit import. After a while, my points are going to show up at exactly the location that I need them. So this is super, super interesting and easy to do when you have like a geolocated point cloud, because like you don't need to like manually position your GLB files, you defining the elevation for them and things like that. And once you're done with this, you can simply hit confirm, and this will create a new point cloud for you. So I already created one over here, and I can just go into select the drone deploy point cloud, and you can see that like this is already defining the shape of my terrain. Cool. There are other things that we can do over here, and there is also the step that I usually suggest. Depending on how your point cloud is, you might have like very open areas without any information about that area, and you need to extrapolate in between. So you can explore different point planning modes as well. Cool. So at this process, we're going to just like limit and 10K points, check your units. So you are always working with meters, define your geolocation point, and then after that result, you can explore different geolocation different point planning modes to see if you get the best result possible. Okay, so I'm gonna set this as my initial terrain, and there you go. So now let me just remove this shape from here. So now my terrain is adjusted. See how like the area that is outside of my point cloud, there is like a big drop over here. So this is the type of thing that once you start changing the point planning modes, you might get like a different result of how the software extrapolates for the parts that it doesn't have any information for. Cool. There you go. Also, oh, we only have 5 minutes left. I knew that this was going to take a while. I will keep on going over here with the manual positioning, and today I won't talk about the tips and updates. I'm going to leave this for the next session. But like I think that's important that we also understand how to create the manual custom terrain, right? So the last part of the custom terrain that I want to cover today is how to create these information, a new terrain, if you don't have any drone scans or any 3D models to take through, or like any point clouds or not. You have like just rudimentary information, which is basically a drawing with contour lines or like a 3D model that you know where it's going to be placed in terms of the elevation. So we just need something that will give us like a reference for how that topography is supposed to be, right? And the compatible file formats is just like what we use for drawing overlay and the models that you can import. And then these can come from civil model, civil drawings, grading drawings, geotechnical drawings, anything, right? So you just need something that you can use as a reference to define like the elevation of points. So let me hide this model over here and the sound. And in this case, I brought in a drawing from Bluebeam. However, when I placed this drawing over here, I was looking for my contour lines, and I noticed that they are quite faint in this drawing. So there is this little trick in Bluebeam that you can adjust this shape, this drawing to show you exactly what you want, right? So I'm going to go first on document, and I'm going to click on crop pages to focus only at the area that I need. So I'm going to get a window over here to crop it, and I'm going to get just this area over here to import to cmBuilder. So now that I crop my pages, I noticed that the contour lines are showing with a light gray color, whereas like the noise is showing like with a dark, with like black color. So you can go into your document, and this can be used for like any other things that you need in Bluebeam. It's a good trick for Bluebeam. You can go over here and go into document and color processing. So this will allow me to select the source color and change it to another color. So I'm going to select everything that is in black in my drawing. I want to become transparent. So you see that the transparent, like now everything that is black is transparent. And everything that was the light gray, I want to become like black. So I'm changing, I'm hiding the noise, and I'm also highlighting what I need in terms of information that is the actual contour lines, right? So now I have a good drawing to bring into cmBuilder. And once I bring that drawing to cmBuilder, you're going to see something like this that is easier for you to find out where the contour lines are, okay? And also a good practice is for you to lock the drawings once you have them in the right space, because now you won't be able to select them unless you double click. So if I click once, I won't be selecting this drawing anymore. Cool. Now let's go to the custom terrain tool. And the process is that I usually for this, if I'm using contour lines, I will deactivate the topography lines, and I will start from the default project map, just so like I can like get a clean start. And we are going to now create a terrain from points. So the process now is that I'm going to add these points manually. I'm not going to import them from somewhere else. So I'm going to click on a location that I know what is the elevation for that point. So if I click on this area, I know that this point is supposed to be on 772 feet. So I'm going to just type in over here 772 feet. And if for some reason you didn't type in at this location, you can just go in here and then type in over here. So this is showing in feet and this is in meters just because of my settings. But I'm going to go ahead and just change this to show in, oh, this is showing in meters because I'm working with the UTM zone. So if I change this to scene, it will show in feet. Okay, so basically you can now type in also the information about the elevation of those points from here, and the software will understand, right? But let's go ahead and do one of these lines. So if I go ahead and do that, so let me delete these points. So the quickest way for you to do this process is for you to define the elevation of the first point that you want to create, right? So 772. Always work on your 2D view because you're going to be making sure that you're selecting the correct location of your points. And then you're going to select this over here. Use the last selected points elevation, because this will lock the elevation of your points. Every time that you add a new point, we'll just use the previous one, the previous elevation. So now it's just a matter of us creating a lot of points on this contour line, right? And the level of accuracy over here, I would say that you don't need to create like points that are too close to each other. So this distance that I'm putting over here, that's around like 15 feet, 20 feet, that's totally fine. Like you can put more whenever you need more resolution. Let's say, for example, over here, you want to make sure that this area is correctly covered, or where you have like sharp turns of your contour line, like this one over here. So you can just like create more points on this area to make sure that you get a better accuracy of that area. But just keep in mind that you don't need to be super, super precise about this, because there will be some approximations of the shape, right? So that's it. And also in terms of like which contour lines you're going to select, you also don't need to do all of them. You can skip a couple, because again, the software will propagate what's happening in between. But if there is like a huge difference, like a huge spacing in between the contour lines, it's better if you keep like, if you use them. But like whenever the contour line is a little bit denser, you can like skip a lot of them, because like the extrapolation from here to here is not going to be that bad. Okay.
Can I just chime in here? So just
yeah,
after talking to a lot of customers, this is often the best solution to try, to be honest, just because you don't really need any other softwares. You don't need lots of pre-processing done by, say, a BDC team or something like that. You literally just need a drawing with contour line. There's some manual aspects to it, but you can control it all yourself, right? So, you know, while the automated process around like getting the surfaces or CSVs into it is nice, of course, when it works and it's more robust. Often, if you're just doing something quick, it might be easier to do it this way. Just feedback from customers that we get, because almost every drawing package has a drawing with the contour line like this, and you can just import it as any other drawing and then go from there.
And now that I think of it, I should have started with this one.
Yeah, could have started with this, because this is like V1. V1 is bring a drawing in, just like you always do. It just happens to have contour lines, and then you pop a couple points on there and you adjust it, and you're done.
Exactly.
So yeah, it's okay.
When you look at sideways, can see the comparison of like where these points are located and where the default terrain was created, right? So this is a good way for you to kind of like set this up. Oh, to compare like what's going to be the difference between the original terrain to the default, to the one that you're creating. So I'm going to cancel this because I already have like an option that is created over here with all the control lines. And then once I open them, you can see like more or less what is the level of resolution that I used over here and what is the impact that this has on the terrain, right? So when I confirm it and I want to set this up as my initial terrain, we can see the difference between this one and the default project one and the control line one. So like this is the default project and this is the one using the control line. So you're going to see like quite a big difference at this location. Cool. So this is it for custom terrain. I knew that this was going to take a long time to explain because I wanted to go in depth over here, especially because there are so many other situations where like you don't know exactly what you're going to get in terms of like data available. So it's just a good thing to know like that you have all of these different options for you to go through, right? So yeah, so basically that's it. Okay.
Thank you, Pedro. I'm going to chime in here. I know we're 3 minutes over, but I want this group to hear it first because this is the core community. So we are just something that's going to come out hopefully in the next week or two. We're going to have our a second version of Site Plan Summit, which is our own user conference that we here in Vancouver. Last year we did one. It was small. Some people that are on this call were here, just the local team. Local customers and community. We're going to open it up to a wider audience if people want to come to Vancouver it's going to be July 9th and 10th. We got a great plan of speakers. Ben, it looks like, hopefully Ben who's on this call will hopefully join as one of our speakers. We're going to try to get people in from Drone Deploy, Autodesk, Procore, etc. So putting it together, but I just want you to hold the date, July 9th, 10th, if you're open to it. And we're going to have our kind of second Site Plan Summit, which we will get an opportunity to meet other people in the community, meet our product team, and also just hear like great inspirational people talking about doing cool things in construction. So more to come on this.
Actually, I had
Pedro's not ready for that. You are not ready for that.
No, yeah, but like I also had an idea about like the last part of the workshop over here. Should I explain and we have it recorded, or should I keep it for the next one?
Sure. If you want to stay for another 5 minutes, you're welcome to. Or you can just drop off and we'll send you the recording.
Cool. Yeah, so let's go with the tips and updates, right? So quick updates that we've done in the platform lately. So one of them is the ability to export a schedule as a CSV file. So once you have like a project that you already connected with a schedule, and this will only work for projects that are already connected with a schedule, you have like this list of milestones over here these are all milestones that are connected to a schedule file. You can now download this schedule and open this in Excel, something like that. And then once you have it, you can do like adjustments to these files, to this information, like names, dates, and whatnot. And then you can import that back into cmBuilder using the update schedule feature, right? So sometimes like some people ask us, do you have like an option like that? Because you can now book edit like a bunch of milestone names, dates, and so on and so forth. So it's a great thing to try. The second one is like something that I really wanted to show, and it's something that a lot of people will really enjoy this new tool, is the new sketch update in terms of like projections. So before, I already talked about this in the other workshops, before you could only reuse a sketch or create a sketch from an existing geometry if that geometry was a 3D shape, like an imported shape as a 3D model, or it would be like a massing that you created. So what I'm talking about is this. So let me just hide everything that is not level 1 over here. And then I will be able to select this slab over here. Let's say that I want to do an excavation with this slab. I can click on excavation, click on cut. And when I'm drawing my sketch, I can use this project tool to select the shape that exists over there and this will create the projection for that shape. So sometimes you're gonna get something like this, but it's only because that geometry, it's a little bit weird when that geometry was created originally. So you can just go ahead and like do your sketch for the part that it didn't capture properly, and it will create an excavation area for you over there, right? So this was the previous process where you could only use a 3D geometry that already exists, but you now can always also reuse other geometries from cmBuilder. So for example, if I want to create a 3D line that is around this zone, I can go and click on project and then select the zone. So now I just took the sketch out of that zone, right? So it didn't need to create the sketch again, and it's way more accurate and way faster for you to do those things. So everything that uses a sketch in cmBuilder can use this tool. So for example, if I'm doing fences over here, I can just go ahead and select any fence, and then click on project, and then go ahead and select an existing shape, confirm, and now I have a fence that is going to be generated on top of that shape. Cool. So you can reuse the sketch from basically any geometry that's controlled by a sketch. So I can reuse the sketch from a fence, from a zone, from a 3D line, and so on and so forth. The only thing that you cannot use for that is the excavation tool.
Can you stop for a sec?
Yeah.
Can you go back? So for those who have, so if you have premium and enterprise and you get those branding there, if you ever get a situation where the logo's on that side, you can just swap it out. Sometimes we get that. So yeah, I just noticed that. So if you ever get that, just change the position. So if you're like sketching from left to right versus right to left, you just notice the logo showing up on the wrong side of the fence. You just swap it with that. You don't need to redo the sketch. And then the overlap thing, you might want to just talk about the overlap concept.
Yeah, something that when you create a fence or like any linear objects from our resource library, by default, it will show as a no overlap. So you see that at this area over here of the fence, there's not enough space on this segment for us to add another fence. So we just like divide those openings in between like the fences, but you can select this option to overlap with the excessive length. So we will overlap the panels a little bit one to another to close that gap. So this is just a quick reminder that that you can change that. We're actually going to change soon for this to be the default one.
That's so just you know, like fences you can in the physical world obviously overlap, like most of you already know, but some elements for accurate QTO, this is why we added this. I'd say you're doing lock blocks or something that it's concrete. In theory, you can't overlap, or else you want to know the count, right? That you can export after for slightly just for like your general condition or those costs, general requirements. So yeah, you can toggle the accuracy of that.
Cool. And the last 3 updates that I want to show is that also something that a lot of people requested is that the increased projection limits, right? So before you could only project on the map from drawings and 3D labels, you can only project up to 7 elements. We increased this now to 13, so you can project more elements to follow the ground, right? So basically what I'm talking about is that whenever you have a drawing, for example, so if you have like a bunch of things projected on the ground, a bunch of drawings, this will be grayed out, so you won't be able to select and project more objects. The idea is that now the limit is 13, before it was 7. Cool. So this is something that a lot of people requested, and it's there already. In terms of video export settings, now we have better export settings for the videos. So when you have a presentation video already created, you have the ability now to choose whatever video quality you have over here. It's better than what it was before in terms of you defining that quality of your output. And the last thing is that our conversion engine was updated recently, and we now are using the different style of converter. It's called ODA, and this allows us to create faster conversions. So whenever you bring in new files, IFC files, Revit files, and whatnot, they will convert faster than what it was before. They're more reliable as well, so like it can take more complex geometry, so you will fail. If you fail less, like some models are very, very complex and will have like a lot of small parts, and this was creating some clogging on the conversion system, and we changed this now, and we are able to like convert more parts. And now it also supports IFC4, which before it only support IFC 2x3. Cool. So everyone that uses Revisto or any other like softwares that use IFC4 as an export can now use the new converter without any problem. Cool. Okay, I think this was a wrap, like 10 minutes later over here. So just to recap what we talked about today, we had the terrain customization, like using drones, using point clouds, using control lines, and tips updates about everything that is new. So we're probably going to be stick around over here for like 5 or 10 minutes more if anyone has any questions, but we will follow up with the recording to your emails and with a quick survey link so you can let us know what you think about our workshops, what do you want to see in the next workshops, and so on and so forth. Cool. So thank you, guys.
Thanks. Good job. Good job, Pedro. Thank you. Reach out to us if we can be of assistance.
What is the ETA on being able to convert to terrains? Yeah, Josh, I knew that this was going to strike close to you, but this is something that we really want to do, but at the moment we cannot work at this feature specifically because we are working on other things related to the excavation tool. That is kind of like we need to do that first before we bring in this new feature of using two terrains, right?
We still intend to do the comparison between two surfaces. It's just should be less than that, but we had to do some underlying tech stuff first to be able to do that. So that's where we're at in the process. So the whole excavation optimization stuff that we've been working on. Thanks, Mark. Thanks, Eric. Thanks for joining.
Cool. Should I cue the music in?
Oh, you could. This is like outro music at the Oscars.
Yeah. Is it too loud? I don't know. I can hear it because I'm not.
No, it's great. Great. Thanks, everyone. Have a great day.
Okay, let's close this then. Bye.